this is Mr. T, and today we're going to have a lesson on trigonometry. It's our first lesson on trigonometry. Trigonometry, in one respect, is about triangles, so before we get into trigonometry, let's just review what we know about triangles. There are also applications of trig that have nothing to do with triangles that we'll talk about as we get into this. So let's talk about triangles. We all know some very basic things, and what we're going to talk about here is, I'm sure, common to all of you. They've got three sides. We could have a right triangle. What makes a right triangle? Okay, I'm sure you all know a right triangle means one of the angles is 90 degrees. There could be an acute triangle, where, if you remember from geometry, acute angles are less than 90 degrees, so all three of these angles are less than 90. And we can have obtuse triangle, where one of the angles is bigger than 90 degrees. On all these cases, you might remember that the sum of the angles, we'll be using these in this fact in our problems today, is 180 degrees. And we're going to be focusing on right triangles today, so if we label the sides of a right triangle, we'll be doing this consistently. The right angle will always be C. We'll be using capital letters for the vertices and the angles. And our sides will be opposite that, so if we go opposite angle A, we have side A, opposite B is B. Opposite C is little c, and that's the hypotenuse. And we probably all remember this Greek dude Pythagorean theorem that relates the sides of a right triangle. So we'll be using that, or Pythagorean theorem. And also we'll be using some relationships, or what are called special right triangles, that you might remember from geometry. We have one of the special triangles has 30 degree, 60 degree, and 90 degree triangle, 30, 60, 90. And on that case, the side opposite the 30 is 1, square root of 3, and 2, or multiples of those numbers. It doesn't have to be those exact numbers. And our other special triangle we'll be tying into our trigonometry is a 45 degree and 45 degree 90 right triangle. This would be isosceles, so if these two sides, whatever that side is, this will be the same. And using the Pythagorean theorem, we could figure out that this side is radical 2. So we'll be using these triangles today. So let's talk about a little bit about trig. Trig refers to a set of functions, 6 particular functions. And if you remember the definition of a function, it's like a machine. It processes inputs and produces outputs. So if we have a function machine, it has inputs, one or more. In our most math functions that we're dealing with, we've got one input, and it produces a value and output. Key thing for trig functions is that each unique input gives a unique and the same output every time. For trig functions, our inputs will be the measure of an angle, and our output will be a ratio. Depending on which of these trig functions, the ratios will be different, but the ratios will be the sides of, comparing two sides of a right triangle. We'll talk about those ratios on the next slide. Again, the names of the functions are the sine function, cosine, tangent, secant, cosecant, and cotangent. So let's look at the definitions of these functions. For these primary functions, sine, cosine, and tangent, the relationships are shown here. Now we have a picture that this refers to, so we pick one of the angles on a right triangle. Again, this is a right triangle. And the side opposite that, the side adjacent touching it, and the hypotenuse is always opposite the right triangle. The sine of an angle, sine of theta, is the ratio of the opposite side to the hypotenuse, adjacent to hypotenuse for cosine, and opposite over adjacent to tangent. These three functions are reciprocal functions. So cosecant is the reciprocal of the sine, so we flip the ratio. Secant's the reciprocal of cosine, and cotangent reciprocal of tangent. Sometimes you'll hear this talking about here, SOHCAHTOA. That conjures in my mind a Native American warrior or a Native American princess, but it helps you remember. The S stands for sine, is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So it's a way of remembering these relationships. So let's look at how we apply these. So let's say we have a triangle. We don't know the specifics of an angle, but we have here a triangle whose sides are 3, 4, and 5. And we want to find the values of the trig functions. Remember, trig functions have an input of an angle. So we want to evaluate the sine of theta, the cosine of theta, tangent of theta. Let's start with those, and then we'll do the reciprocal functions. So on our problem, sine is opposite over hypotenuse, so 3/5. Cosine is adjacent. The 4 is adjacent, touching the angle, so 4/5. And the tangent is the opposite over the adjacent. The inverse of the sine is the cosecant, abbreviated CSC. That's going to be 5/3. The reciprocal cosine is the secant, which will be 5/4. And finally, the cotangent is the reciprocal of tangent, which is going to be 4/3. Just an important part about sine and cosine. The hypotenuse is always the longest side, and that's our denominator here on sine and cosine. So the top number can never be equal to or bigger than that. So sine and cosine values will never be, the ratio will never be bigger than 1. Tangent and the inverse functions can have values that range for all real numbers, but the range for sine and cosine, it only goes up to 1. And actually on a triangle it won't even include 1. Let's look at another one. So why don't you oops, I went the wrong way here. So you could be trying these. Now this one we're only given 2 of the sides. So before we can fill in all of the things, we can do the sine of theta here. Now this time the theta is in a different place. So opposite is the 80. And the hypotenuse is 100. And both of those are divisible by 20, so we have 4/5. Now we need to find this side. Now you may know the Pythagorean triples and know what this is, but we would have to, if we call this x, if we want to find that side, we would have to use the Pythagorean theorem. And solve. So x squared would be the square root of 100 squared minus 80 squared, which is going to be 60 for, I'm sorry, x, I already took the square root here, so x squared would be 100 squared minus 80 squared, then when we square root we just get x. So if we put the 60 here now, cosine of theta is 60 over 100, which reduces to 3/5. And again, our tangent would be 80 over 60, which reduces to 4/3. And then our reciprocals, the reciprocal of the sine, again, is the cosecant. So we don't just say cosecant or sine, it has to be of something. We sometimes show parentheses, and when you use the calculator, or depending on the expression, sometimes the input variable, like when we use f of x, will be in parentheses, so it can go either way. But you can't just use this name of the function, it has to have an input. This is going to equal cosecant's reciprocal of sine. Secant of theta is the reciprocal of cosine. And again, cotangent is the reciprocal of the tangent, and that's going to be 3/4. When we deal with trig, we have two kinds of ways of working the problem. Sometimes we want to find the exact value, and sometimes we'll be using a calculator and rounding the answers. When a triangle includes the special angles, 30, 45, and 60 degrees, we usually give the answers in exact value. So let's look at this triangle here and let's figure out, we'll just do it for the three primary functions, sine of theta, cosine of theta, and tangent of theta. And here actually I should be, instead of theta, we want to do it of some specific functions. So we'll put in the particular values here. Let's do the 30 degrees first. So the sine of 30 degrees is opposite over adjacent is 1/2. Cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. Remember, we don't leave radicals in the denominator, so we have to rationalize that. So these values for these special the trig values for these special angles are going to be something that you're going to want to memorize. Later in the lesson we'll talk about an easy way to memorize those. Let's do the 60 degrees. I didn't mean to do these in a different order, but so be it. Let's do that as I wrote it here. Cosine is adjacent, so we're doing 60 adjacent over hypotenuse, 1/2. Sine of 60 is going to be opposite over hypotenuse, and tangent of 60 will be opposite over adjacent, square root of 3 over 1, which is just square root of 3. And again, if we do that quickly for cosine, let's just make a little table here. Sine, well, we only have one angle because both of them are the same, 45 degrees. Cosine of 45 degrees and tangent of 45 degrees. Sine is opposite over adjacent, 1 over square root of 2. And if we rationalize that, we get square root of 2 over 2. Cosine is the same because it's adjacent over here, 1 over square root of 2, and when we rationalize it's going to be this. And tangent is opposite over adjacent, which is 1 over 1, which is 1. When we're working on right triangles, we already talked about this, so this is just the labeling, so I think we can skip over this slide. And when we're solving triangles, we may be using the Pythagorean theorem to find a missing side if we know two sides. And if we know one side and an angle, we'll be using the trig functions to find the missing information. So let's solve a couple triangles here. So here we have one here. We're given one side and one angle. So we want to solve the rest of this. Let's label these so we can talk. Let's call this A and B. And we know it's a right triangle. We were told that, so it's 90. So how do we figure out angle B? Well, we know these two angles. Since this one's 90, these two angles, so that we get a total of 180, have to equal to 90 degrees. So we know the measure of angle B is going to be 90 minus 24 degrees, which is 66 degrees. Now we need to find side A and side C. To find side A, we can pick one of the angles, so let's pick this one, the given angle. A is opposite of 24, the known angle, and the only other number we know is the adjacent side. So if we look at SOHCAHTOA, we know the adjacent to the angle we're looking for, so we know adjacent, and we're trying to find, in this case, A, the opposite. these break up into triples, and when you solve an equation with three unknowns, we need to know two of them. So the only one that we have enough information to solve is this one. So we can set up the equation tangent of 24 degrees equals a, which is the opposite side, over 8. Now we have to solve that for a, so we multiply both sides of the equation by 8, and we get 8 times the tangent of 24. Now 24 degrees is not one of our standard angles, so we're going to end up using our graphing calculator, so let's turn that on. Now anytime you're using trig on a graphing calculator, you need to press the mode button first and check this. Now angles are measured in two ways: degrees, which you're familiar with, and something called radians, which we'll talk about later. So before you use a calculator for trig, make sure it's in the right mode, and for triangles we want to put it in the degree mode. Our trig functions are here: sine, cosine, and tangent. And if we want to compute what we have here, we need 8 times our tangent of 24 degrees, that we put it in degree mode, so 24 is in degrees. And we hit enter, and we get approximately, let's just round it to the nearest tenth, so A is 3.6. Now we could find C using, now that we know two sides, with the Pythagorean theorem, but we'll get a quicker and more accurate answer if we use trig. So let's use the given 8. So this number is rounded, it's not as accurate, so let's use our 8. So if we look at our SOHCAHTOA again here, oops, I didn't mean to erase that part. Let's get a red pen back. We know our angle, and we know the adjacent side. And now we're trying to find hypotenuse. So again, we don't know the opposite. Well, we do know it, but not the exact value. So again, that's going to tell us to use cosine. So we can set up an equation here. Cosine of 24 equals 8 over c. We can make this over 1 and cross multiply. Cosine of 24 equals 8. Now we have to divide by cosine to get c by itself, so 8 is divided by cosine of 24 degrees, and we can put that into our calculator here. 8 divided by cosine of 24, and we get about 8.8. Again, we could have found this third side using the Pythagorean theorem, but it's going to be quicker in my mind and in my idea, and more accurate doing the way we did it. Now let's look at our second problem. Here we have a special right triangle, so we don't need to use our calculator. We're going to give an exact value. Again, let's put letters here. So this is B. We need to find A and C. Now we know A is 30 degrees. And to find little a, opposite and adjacent, so we can set up tangent of 60 degrees equals 9 over a. And from our earlier work, we know that the tangent of 60 degrees is square root of 3. So square root of 3 over 1 equals 9 over a. So we cross multiply and divide by radical 3. And let's rationalize that. So we get 9 radical 3 over 3, and that reduces, so we end up with 3 radical 3 for a. And to find c, we could use the 9, which is opposite in here, so we can set up, I'll put it up here, it's a little out of order, but opposite over hypotenuse is sine, so we have sine of 60 degrees equals 9 over c. Sine of 60 is radical 3 over 2. We figured that out earlier. Again, cross multiply, so radical 3 times c is 18. Divide by radical 3, and we're going to rationalize it. We end up with 6 radical 3 for our third side. Let's just quickly look at an application for a trig. Let's say we had a flagpole and the sun was shining on this side of the flagpole. And you know, when the sun shines on something, it creates a shadow. So this is our shadow. Let's assume the shadow, we could measure it with our pace or with a ruler, yardstick. Our shadow was 10 feet long. And we either estimated or measured using a tool called a clinometer this angle here, looking up at the sun, as 67 degrees. And we want to know the height of our flagpole. So relative to this angle, we have here opposite, and we have adjacent, so that is a tangent function. So we know tangent of 67 degrees equals h over 10. So h is 10 times the tangent of 67 degrees. And we use our calculator here. So 10 times the tangent of 67 degrees. And we get 23.6 feet. So our flagpole is 23.6 feet high. And finally, our last example, we have the sun shining down on a house. The house has an overhang. The sun, when we look up at it, is 63 degrees. Our house up until the overhang is 16 feet, and we want to find the width of the overhang. Now this is we assume this is a right angle. So these two angles have to add up to 90. So this angle has to be 27 degrees for those two to add. So now again we are going to be using the tangent function, opposite and adjacent. So we can calculate the tan of 27 degrees equals opposite, which is our width of our overhang, divided by 16, the adjacent. Again, to solve, we'll multiply both sides by 16. Then we can use our calculator here. So we get 16 times tan of 27 degrees. And we get an answer of 8.2. That's a pretty big overhang. Now, I made up these numbers, and obviously these numbers aren't very accurate unless this overhang was maybe an overhang for a porch or something. Anyway, this is our introduction to trig, and see you around town.